All right, the next thing that we're going to look at with our triangles, our right triangles, is we're going to spend a little bit of time working with some trigonometric ratios. We can use trig ratios, sine, cosine, and tangent to help us out finding different side lengths and angle measurements. Okay, angle measures and side lengths in triangles are related in proportional ways. In a right triangle, we describe those relationships using trigonometric ratios. The trig ratios or functions relate the side lengths of a right triangle to its acute angles. Okay, these are things that you're going to have to remember. The sine of angle A. Sine, we're going to abbreviate that as S-I-N, sine A. And sine is always equal to the opposite leg over the hypotenuse. So I'm just going to abbreviate that and say sine equals opposite over hypotenuse. Since it's the sine of angle A, well, here's angle A right here. So from that reference angle, we look at to the opposite leg. That distance is going to go in your numerator, and the distance of the hypotenuse is going to go in your denominator. That's how we define sine. We define the cosine then of A. I'm going to stay with that same angle. Cosine, or COS, okay, cosine is the adjacent leg divided by the hypotenuse. Okay, so if I'm looking for the cosine of A, cosine is the adjacent leg. The word adjacent means next to, so the leg that is next to A would be this one right here. That distance is going to be divided by, again, the hypotenuse. Okay, and then lastly we have what's called the tangent of A. And for tangent, the tangent is the only one that doesn't involve the hypotenuse. The tangent is the opposite leg over the adjacent leg. So we're going to take the side lengths. Here's A again. The opposite leg, however long that is going to be divided by however long the adjacent leg is. Okay? So one of the ways that for ages that we've tried to memorize sine, cosine, and tangent is we say so, S-O-H, S-O-H, S for sine, O for opposite, H for hypotenuse, ca, C-A-H, okay, and then the last one is toa, T-O-A. Okay, so if you hear me say so, ca, toa, that's how I remember what order to put the fractions in for sine, cosine, and tangent. So, ca, toa. You may want to write that down and use it as you work through the rest of Chapter 8. Okay, here's what we're going to do today. It says write trig ratios. What are the sine, cosine, and tangent ratios for angle H? Okay, and again, it's very useful. You have to know which angle we're talking about. So the sine of H, you want to circle, there's angle H right here. So for sine, we're looking for the opposite distance divided by the hypotenuse distance. So if I go from angle H and I look to the opposite leg is 12. And the hypotenuse of this right triangle is 15. So I would set up the fraction 12 over 15. Now when it comes to working with fractions, we always want to reduce the fraction. So 12 over 15, 12 and 15 are both divisible by 3, so that's going to reduce down to 4/5. So I would say the sine of H is 4 over 5. Okay, when it comes to the cosine of H, here's angle H again. Cosine, remember, is the adjacent distance of the leg divided by the hypotenuse. So from H, which leg is adjacent to H or which leg is next to H? That would be the 9. And the hypotenuse is still 15. Okay, 9 over 15 is the fraction. We always want to leave our fractions in reduced form. So that would become 3 over 5. If I divide the top and the bottom by 3, I'd get 3/5. Okay, and then the last one is the tangent of H. So here's H. Tangent, remember, is opposite over adjacent. Okay, so from H, the opposite leg, if I look opposite of that, I'm going to get 12 over the adjacent leg to that would be 9. Tangent is the one fraction that is possible to be greater than 1 in value. 12 over 9, you can see the larger values in the numerator, so that does have a value greater than 1. I'm still going to reduce it. 3 goes into both of these. I'd say the tangent is 4/3. Okay, make sure when you set your fractions up today that you reduce your fractions. Okay, here's another example that we can work with. It says find the sine, cosine, and tangent for the ratios for A and B. So for angle A, the sine of A, well, you want to circle A. That's where angle A is. So sine is opposite over hypotenuse. So from angle A, I'm going to look at the opposite leg. Okay, the opposite leg would be 15. And the hypotenuse of the triangle is 17. So I'd use the fraction 15 over 17. Now that fraction doesn't reduce. They don't have a common factor, so we just leave it 15 over 17. The cosine of A, okay, so I'm going to stick with that same angle. The cosine is the adjacent leg. That would be the 8. The adjacent leg divided by the hypotenuse. The hypotenuse of the triangle is still 17. And the tangent of A. Tangent is opposite side over adjacent side. So the opposite leg is 15, the adjacent leg is 8, and we would just leave that as 15 over 8. Now pause the video. I want you to go through and I want you to find the sine of B, cosine of B, and the tangent of B. Okay, and there you go. Hopefully you had those values listed. Okay, and there's some other things that we're going to look at. All of those fractions that you are creating when you create the sine, the cosine, and the tangent, we could express them as decimals, and we are actually going to do that a little bit down the road. But for now, just get used to setting up your fractions for your sine, your cosine, and your tangent.